Okay, so this is what you're going to need to use the calculator to do your normal probability. Whoop, let me clear that. To do your normal probability problem. So I've got just a real quick set of calculations to do right here. So if I have a problem where the mean is 100 and the standard deviation is 20, I could be asked any of these types of questions here. So the first one is I need the percent that falls between 90 and 125. All right, so we go over here, second, vars, and the distribution that you want is normal CDF. So I go down to normal CDF. Now, the way that I have to put the information in is lower bound, upper bound, mean, standard deviation. All right, so the lower bound for this problem right here is 90. And I separate everything with commas. The upper bound is 125, comma. The mean is 100, comma. And the standard deviation is 20. All right, so I just hit enter on that, and I get the probability. And to turn that into a percent, just multiply by 100. All right, so that would be 58.58% for this one. All right, if I want to do the percent that falls below a number, so in this case I've got 70. All right, I go back in, pull that up. Now below means that, here, let me write this down. All right, so below this means that my x is less than 70. All right, so if my x is less than 70, that means my lower bound is negative infinity. Now I can't write negative infinity in here, but I can write a really big negative number. So I'm just going to say -1 and maybe 1, 2, 3, 4, 5, 6, 7, 8 zeros. That's good. That's a really big negative number. That will stand in for our negative infinity. Comma. Upper bound would then be 70, comma. The mean is again 100. And the standard deviation is 20. All right, so there's my probability multiplied by 100. And I've got my percent, 6.68%. All right, now when I have one like this where the percent is above, all right, that means what I'm looking at here is that x is above more than 85. So in the case of this one, my lower bound is going to be 85. So I go back in here. My lower bound is going to be 85. My upper bound is going to be positive infinity. So now I want a really big positive number. So 1, 2, 3, 4, 5, 6, 7, 8. We'll stick with that as our really large number. All right, and then again the mean, which is 100. Standard, whoop, too many commas. Standard deviation, which is 20. And I've got my probability multiplied by 100 to get the percent. So 77.3, that would round off to 34%. All right, so all three of those, all right, that's how you're going to input it. If you're looking for the endpoints, which correspond to a middle part of your probability graph, all right, so I'm going to come over here and we're going to look at what that means, right? So I've got my probability graph over here, my normal distribution. The middle is the mean, so for us the middle is 100. I'm interested in the middle 95%, so that means 95% of the curve lies between these two values. That means that 5% of the curve lies in those tails. So half of 5%, or 2.5%, lies in each tail, 2.5% in each one of these tails. Okay, so in order for me to calculate the boundaries that correspond to this, I have to do two calculations. I have to do one for this, and I have to do one for this. So the one on this side, right, is going to be, now again, the inverse normal always gives area to the left. So for this side, we're looking for that. So that would be 2.5% or 0.0025. Yes, 1.20025. All right, and the way that we put that in, let me make some space here, is again, go back into the distribution. This time you're going to go to inverse norm, because what you have is the probability. What you need is the boundary. So now we're going backwards. So that's inverse norm. And what inverse norm needs as the input is, hang on a second. Let's see what, oh crap. Sorry, I'm trying to do this on my other calculator, which shows me the menu. Is the area first, so that would be the 0.0025, 0.0025, then the mean, then the standard deviation. Okay, so then the mean, which for us is 100, and the standard deviation, which is 20, and I get 43.85. So this lower bound here, well, 43.86, I guess, if I round it off properly. So this lower bound, here, 43.86. All right, to get the upper bound, again, because what the function gives us is only to the left, I'm looking from here. I am looking from here all the way to the left. I'm also including this 95% here. All right, so I have to take my 95%, add the 2.5% to it. All right, so that's going to give me 97.5%. So when I move the decimal over, that is 0.975. All right, so I go back to my calculator and I put in inverse norm, and then the area, the new area, right, which is 0.975, comma, the mean, which is 100, and the standard deviation, which is 20. And I get the other side of this, which is, again, if I round this to two places, it's going to be 139.20. All right, so this one is going to be 139.20. Okay. All right, I think that covers everything that we talked about. All right.